All right, guys, we are going to get a little bit into research methods. This is Unit 2. Some textbooks will put uh, will put Unit 1 and Unit 2 together in the same unit. Others, like ours, have it separated. Um, the way I did it was I went ahead and separated them because I think it's going to make it easier to study. But we're going to go over about 20 slides today. I don't think this will be super long video. The big thing we're going to do mostly today is terms. So make sure you've got pencil and paper out. These are going to be terms that you'll be making your flashcards over and all that. But we are going to get into research methods. Fun, right? Yeah, it is a little more exciting than it sounds. Going to college, you're going to take probably 3 or 4 different research method classes because every area of expertise has its own ways of doing research. So we're just going to get a little bit into the psychology's avenue of doing research. Why do we got to learn this? And I talked a little bit about this on Monday, the 14th. Is that psychology is a science. And because of that, you have to have measurements. You've got to have numbers. You've got to have a way to compare. And the best way to do that, we have found, is quantitatively, meaning assign numbers to it. There's 2 different types of value, I guess you could say. There's quantitative, which deals with numbers. The temperature is quantitative. When I say it's 85 degrees outside, we know exactly what that is. Versus qualitative, which has a little more personal, I'm not sure what the word is, significance, or it doesn't really, when I say it's hot, okay, that means something different to me as opposed to somebody who lives in a desert somewhere in the Middle East. Or it means something who normally lives in the Arctic Circle. All right, so that can change. 85 degrees Fahrenheit is 85 degrees Fahrenheit, but hot is subjective. It means something different to each person, and that's qualitative. It references a quality. So you've got quantitative, which is quantity, a number, qualitative, which is a quality, which is a bit more subjective. So that was a little bit longer of an explanation I was wanting to give, but I want to make sure that we are clear on the difference between quantitative and qualitative. But that gets into the fact that psychology is a science. It uses numbers. We have to have measurements. And here are the terms that you're going to have to know. First one is hindsight bias. This is a tendency to believe that after learning the outcome, we knew it all along. All right. When the Patriots won Super Bowl last year, I knew they were going to win it all along, even though they were down a couple touchdowns really late in the game. Mostly that's all bunkus. All right. Again, the hindsight bias, and we'll get into some examples of this a little later. But after the experiment, we get the results and be like, oh, yeah, I knew that was going to happen all along. All right. That's the hindsight bias. Hindsight meaning, looking back, and bias, you don't know what that means. Monday morning quarterbacking. There you go. Another example, y'all remember when Chris Brown beat his girlfriend, Rihanna? Wife said, I knew Chris Brown was violent all along. Yeah, did you really know that? I don't know. Overconfidence is just what it sounds like. We tend to think we know more than what we actually know. An example is 82% of U.S. drivers consider themselves to be in the top 30% of their group in terms of safety. My wife is from Ohio, and there's always a running joke that Ohio drivers are not very good. But according to this, they think they're in the top 30%. Now, we as Kentucky drivers know that that's definitely not the case. But at the same time, we as Kentucky drivers also think we're in the top 30%. So people tend to think they are better than they actually are, or that we know more than we actually do. The Barnum effect. This is a tendency for people to accept very general or vague characterizations of themselves and take them to be accurate. I'm strong. I'm fast. It starts out as very strong and vague, or can be general, but a lot of times we tend to take that upon ourselves as being truth and being accurate. All right, applied research versus basic research. And this is kind of can be a little touchy, but applied research has a clear and practical applications. All right, it's something you can use. What are some ways, what are the best ways people have found to break the sting of drug addiction? All right, any research like that, it can be used, it's useful, and essentially it broadens our knowledge on it. So that's applied research. You can actually apply it to life, and it has practical applications. Basic research is a little different. Look down here at the bottom. Research on therapies for drug addicts has a clear purpose. It has an application. Whereas with basic research, it looks at different questions that you might be interested in, but is not intended to be immediately used. An example might be how kissing changes as people get older. All right, which is a little odd. I know it's a little strange, but it's it's interesting to know. I don't know how you're going to use it, or how does coffee drinking change as you get older, or how do people change when they're drinking alcohol? Those are interesting, but I don't know how you can use those immediately. And that's sort of the difference between applied and basic research. All right, now we're getting a little bit into the nitty-gritty of the science portion of this. And none of this should be new. You've seen the scientific method since you're in elementary school. This is just sort of a recap of what a lot of that stuff you've learned. But a hypothesis, you've heard of it as the best guess. It's probably a tad more complicated than that when we get into psychology. But the idea is that it expresses a relationship, and this is big, between two variables. If A does this, then this happens to B. Okay? Or if we do this to B, then this happens to C. Okay, so there's got to be a relationship expressed. And a variable is anything that can vary or change among participants in the study. If I stop giving grades in AP psychology, then this student behavior will happen. A is the variable is the grades. That is and then one variable is the grades, the other variable is the behavior. So, but there's a relationship there. The grades, affect the behavior. So, anytime you can put affect in there, that's going to help. Here's another example. Does participating in class lead to better grades versus not participating? So participating is the independent variable. That's the thing that that you change, and the dependent variable is what is being affected. So the grade, in this case, participating in class, leads to better grades than not participating. So the better grades is a dependent variable because participating or not participating affects the better grades. So, and I just mentioned the independent variable. This is whatever's being manipulated, whatever's being changed. All right, the time spent studying affects grades. The age in which somebody begins smoking affects health. The amount of time you spend practicing a sport affects your playing ability or your stats. Okay, the what is being changed, what is the independent variable, and the hope is that independent variable does bring change. If the people who spend, let's say for this class, if somebody spends 5 minutes studying for a test and 1 hour studying for a test, the hope is that there would be a difference there, all right? Because if they're both the same, then the experiment is flawed, or maybe I'm doing something wrong in the class or something like that. Maybe it's too easy. So if there's a drug in an experiment, the drug is always the dependent variable. All right, if I give this person a certain antihistamine, how does that affect their allergic responses? And okay, the dependent variable, that is what is being affected, what is being measured in the experiment. It is dependent upon the dependent variable. Dependent variable would be the effect of the drug if you're using that drug scenario, or it would be the grade if you're using the time spent studying scenario. All right. Every experiment needs to have operational definitions. All right? And this helps us to sort of define and sort of box in what we're actually studying. All right. If I'm creating an experiment that looks at, time studying, again, we'll use that one. Well, what exactly is studying? Is it just looking over note cards or flashcards? Is it going back through and doing the study guide? All right, so what is actually meant by studying? So being able to define that, it really helps. All right, let's look at here. Let's say your hypothesis is that chocolate causes violent behavior. All right, first of all, what is considered chocolate? Is it dark chocolate? Is it milk chocolate? Is it cocoa powder? Is it a specific type? Is it Hershey's chocolate? Is it Godiva chocolate? So you want to be able to know exactly what you're measuring. Because if you do a couple experiments, do one with Hershey's and one with Godiva and one with dark chocolate, one with Snickers, you don't really know exactly what you're measuring, because you may have different measurements or may have different amounts for each experiment, so that can throw things off. And then you also want to know, what does it mean by violent behavior? Is it punching a kid in the nose? Is it smarting off? Is it getting into a fight? Or is it just something a little more passive-aggressive? Okay, so what do you actually mean by chocolate? What do you actually mean by violent behavior? Those are operational definitions, and every experiment needs to lay out exactly what those operational definitions are. Sampling. All right, this is how you identify the population you want to study. Now, there is a difference between population and sampling. Population is the entire group, and sampling is a small portion of that group that is, and this right here is important, that is representative of the population. So if the population I want to study is high school students, all right, the population at Fleming County High School, then the population would be high school students in Fleming County High School, but the sample would be a representative sample of the population. So you're looking at it would be the same ratio as boy to girls, white to black, or Latino, or whatever ethnicity that we're looking at. It could be socioeconomic. So the hope is that the sample that I would use would be representative of the population as a whole. And the hope is that the sample would be random, that anybody in the population can have an equal opportunity to be a part of the sample. And when we're getting into the experimental method, we are looking to prove causal relationships, not casual, causal. A causes this happen to B. All right, and you're looking at cause and effect. For example, smoking causes health issues, and you can look at time spent smoking, age began, how many smokes or how many packs you smoke a day or a week or whatever. All right, but you're still looking for that causal relationship. A causes B. There's a couple ways to do it. You can do it in a lab or you can do it in the field. All right, in the lab is usually a bit more controlled, whereas in the field is a bit more, there's a lot more things that can affect the outcome. Things like confounding variables that can affect the outcome. For instance, if the object of an experiment is to prove that A causes B, large amount of smoking 2 packs of cigarettes a day causes health issues. Okay, so A causes B. 2 packs of cigs a day causes health issues. All right, there are some things that can also affect that could cause a change in B that is not A. For instance, being obese could also affect health. So the how much somebody weighs or their BMI could be a confounding variable. Socioeconomic status could be a confounding variable. All right, maybe they just don't live a very healthy lifestyle. Maybe there are other things going on. Maybe they have a drug addiction, or maybe they drink lots of alcohol. All right, these things can be confounding variables. They can affect health. They can affect B, and they are not what you're really studying, which is, how many cigarettes, or packs of cigarettes a day affects B. So those are the things that cause a change in B that are not A are considered confounding variables. And I've kind of gotten ahead of myself a little bit. Heredity is another one. Lifestyle, family can also affect heart. So random assignment. Once you've done a random sample, you randomly assign them into 2 groups to help control for confounding variables. All right, so let's say I'm studying, I'm studying tobacco use in high school teenagers. All right, number 1, my population would be the high school or all of high school teenagers. I hope that my sample would be representative of the entire population based on socioeconomic status, gender, race, or ethnicity, all that stuff. That would be a sample, a representative sample. And then what I would do is create 2 different groups, a control group, an experimental group, and the hope would be that I would randomly assign into each group. So there are a lot of ways to do that. Whenever we're doing a random assignment in class, I'm actually going to use a random assignment generator. You can get them online. I can get them on my phone. But it's just a way to randomly assign people to different groups. And the hope is that will control for the confounding variables. The Hawthorne effect. This is something a little different. But what we find is that even sometimes the control group may experience changes. And this usually happens because people know they're in an experiment. And so because I know I'm being watched closely, I may change my behavior. That change is called the Hawthorne effect. An example, and this comes from an experiment that was done at the Hawthorne Electric Plant. They were studying whether brighter lights or dimmer lights would affect production. Well, what ended up happening was because the people in the factory knew that they were being studied, that is actually one of the things that changed the outcome is in the control group. So you had two groups, two sets of workers. You had one set of workers that things were the same. They didn't change the light level. And then you had an experiment group where they did change the light level. They had it set low and then recorded how much work they got done. And then they upped the illumination and recorded how much work they got done. All right, so you would expect a change in the experimental group. But because the control group knew they were being studied, they saw changes in that too. So essentially, the Hawthorne effect is when you know you're being studied or being observed or being watched, all right, you people have a tendency to change their behavior. Sometimes it's to be what the experimenter wants to see. Sometimes it's something that the person being experimented on maybe wants for themselves. But the Hawthorne effect says when we know we're being studied, we may change our behavior, and that is a confounding variable to keep aware of. Some other variables: experimenter bias. A lot of times this is not a conscious act, and one of the ways to keep that from happening is a double-blind procedure. All right, again, if I'm studying tobacco use in high school, I'm not going to know which students are in which group. All right, that would be double blind. All right, not only would the people not know, but also I wouldn't know. All right, and so the hope is that'll help keep away experimenter bias. That way, I may look at a group and say, well, there's a bunch of people in there whose, their voices are lower. They smell like smoke. They have to be smokers. So they must not have very good health. All right, that's the experimenter bias coming in. And I haven't even seen any data yet. I'm just going by just what I see. So experimenter bias can cause an issue when doing an experiment. So it's always good to have a double-blind procedure where the experimenter doesn't actually know who's in what group. Other confounding variables: the placebo effect. You thinking there's a change when there really isn't. You see this a lot in drug trials, trying to figure out if a drug works or not. They'll hand somebody, one group will get the actual drug and another group will get either a sugar pill or something like that to sort of counteract the placebo effect. A lot of times what the placebo effect says, those that are getting the sugar pill will also all of a sudden they'll get some changes happening. So then that brings up the question, well, is it the drug or is it the person's mind thinking they're getting the drug? Holidays can be confounding variables because people change. Even the time of day, if I'm doing an experiment at 8 o'clock in the morning versus noon versus 3 o'clock in the afternoon when people have been awake all day and getting tired, can have a change in behavior. Couple more slides. Correlational method. Actually, I think I'm going to end here. I'm not going to move on. So anyways, hope that was helpful. Hope that was quick. And hopefully you'll be able to, you got some of the stuff down that you needed. And that's pretty much it. Till next time, we'll do slides 18 to probably 36. So, peace out.